Welcome back, everybody. In this video we're going to perform face and eye detection on still images using the Haar face and eye XML files that are included with OpenCV and Emgu CV. In our project today we're going to use Emgu CV and VisualBasic.net in Visual Studio 2010 Express. However, if you prefer a different environment for OpenCV or Emgu CV, the code that we're going to go through today should translate pretty easily to the environment of your preference. If you haven't had a chance already, please see the previous videos for installation and configuration of OpenCV and Emgu CV. Going forward in this video, we're going to presume the knowledge from the prior videos. Let's get started. Alright, so before we actually get started making our project today, let's take a look at the Haar detection eye and face files that ship with OpenCV and Emgu CV. And again, if you follow the previous tutorials for installations, you're going to have an Emgu install here, Emgu x86 2.4.0, and then from the third OpenCV tutorial you'll have this Emgu, or rather OpenCV install 2.3.1. So what you're going to find in each of these, if we go through a few directories, let's see here, OpenCV, data, and then Haar cascades, you're going to find these two files here, Haar cascade i.xml and Haar cascade frontal face default.xml. So what these are is these are huge XML files that contain these data, large amounts of data. And what's going to happen is we're going to call a OpenCV function within our program, and it essentially reads in this data and parses through the picture with a tree-like logic that allows it to determine if there's a face present or not, and if so, where. These files are made by a really complicated machine learning process, which we're not going to get into in this video. As you can see from the progress bar on the right here, these files are very, very long. But rather than making our own today, we're simply going to take the default Haar cascade XML files that ship with either OpenCV or Emgu CV, and then perform face and eye recognition with those. So with the Emgu install, you'll see there's only two distributed, the Haar cascade eye and Haar cascade frontal face. If we go into the OpenCV 2.3.1, OpenCV data, and then Haar cascades, there's substantially more options here. For example, we have eye, and then we have frontal face, but we also have frontal face alternate tree, alternate 2. I believe there's a left eye, there's a left eye and a right eye that are separate to provide slightly more accurate eye detection, but that's not really necessary. For our simple example today, we'll just stick with the two that ship with Emgu CV, Haar cascade eye.xml and Haar cascade frontal face.xml. Alrighty, so now our form's all done and looking nice, so let's go ahead and add our references. Actually, we probably should have done this first, but that's okay as long as we do it before we get to the code. So we can go to Project, Add Reference, Browse, and then we're going to go to our Emgu install, Windows x86, bin, and then we're going to choose our 8 DLLs. Okay, just a moment while it adds those. And then we're going to go back to Project and add existing item. And then once again, we're going to navigate to our Emgu install. Only this time we're going to go into bin and then x86 and show all files, and then everything starting OpenCV and ending DLL. Next, in the Solution Explorer, we're going to choose Show All Files so we can see our references. And then we're going to highlight our DLLs here, and then go to Properties, and change Copy to Output Directory to Copy Always. Alright, so now we're ready to start writing our code. So we're going to have the environment generate the beginning of 4 of our functions for us. So let's highlight our form here, and then we're going to go to Events, and then Form 1 Resize, and double click on that, and there we go. And now return to Design View, and then for each of the 3 text boxes, we're going to have the environment start to write the click event. There's 1 of 3. And 2 of 3, and this will be 3 of 3. And now we're ready to move into our code editor. Alrighty, so now our code's all set up and ready to go. I did realize that I forgot one thing in Design View here. We're going to bring the toolbox back up, and we're going to include 3 open file dialog boxes. So here's our 6 functions, and now we're ready to enter our code. So what I'm going to do to save some time is I'm going to fast forward through the member variables section and the constructor section, and also the form resize section, since that's going to simply be declaring variables, and then the constructor and form 1 resize events are really just going to deal with resizing the form. And then also I'm going to fast forward through the 3 functions here to deal with when the text files are clicked. Those are simply going to bring up the open file dialog boxes we just added, and then allow the user to choose the file. And then towards the end, when we get to the load and process image function, which is actually going to be the Emgu CV part of it, then I'll slow the video back down and we can kind of go through it line by line when we get to the OpenCV functions. So now we're to the last function in our program, load and process image, where we're actually going to make our Emgu CV function calls. But before we start writing that, let's go back up to the member variable section and take a look at some of the variables we declared earlier. So we have 3 images, original, gray, and blank, and then 2 managed CV average comp objects, faces and eyes, and then 2 Haar cascade objects, face detector and eye detector, and then 3 variables for timekeeping, stopwatch, time span, and elapsed time. Now we can scroll back down and start writing our function. So the first thing we're going to do is assign to image original. So image original is going to be assigned new image. And the syntax in Visual Basic is going to be of BGR byte. And we're going to pass in only one parameter to declare the image, and that's going to be the location of the file for the image, which we're going to get directly from the text box on our form. So that's going to be text image file dot text. And let's get a little space to work with here. The next thing we're going to do is we're going to get the gray image, and that's going to simply be image gray is going to be assigned, and here we can simply convert from the color image, so that's going to be image original dot convert. So again, same syntax of gray comma byte, and we don't need any parameters for that. And now we're going to assign to our 2 Haar cascade objects. So we're going to have Haar cascade face detector is going to be assigned new Haar cascade, and here's where we're going to put the string that contains that face detector XML file, which again we're going to get directly from the text box. So that's going to be text Haar face file dot text. And then the same thing for I. Our cascade eye detector is assigned new Haar cascade text Haar eye file dot text. Now we're ready to set up tracking our processing time. So we're going to assign to label processing time that we're processing, and then we're going to make the image box blank, and we're simply, to do that, we're going to assign to its image property the blank image. And then we're going to call do events so that the operating system can update the form for the processing in the label and then also for the image box. And then we're going to start our stopwatch. So now we're to the point where we're going to call the detect function. And the detect function that's actually going to detect the faces and eyes in the image is a member of the Haar cascade object. And that produces a result that we're going to assign to the average comp objects. But before we actually get to that call, recall from our form earlier that we have under speed versus accuracy, we have these 3 options here: fastest, least accurate, balanced, and slowest to most accurate. So what we're going to do is we're going to have some conditional statements here to choose the faces and eyes per those 3 checkboxes. So now we're ready to finally call our detect function. And in each of these 3 conditionals, we're going to have 2 calls, one for face and one for eyes. So let's get started with the face call here. So average count faces is assigned our cascade face detector .detect. And now there's quite a few parameters to this function. Let's go ahead and enter them first, and then we'll go over what they are. So the first is the image. So that's going to be the grayscale image, then 1.2, and more on that in a moment, then 2. And feel free to read the comments that pop up in the autocomplete area here within Emgu CV. Those are very helpful for learning about the function. Next, we're going to have the constant Haar detection type .do_canny pruning. And then to use the defaults in the XML file, the last two parameters we're going to simply make size.empty. And there's our 6 parameters. So for the first parameter, that's going to be the image where the objects are to be detected from. And the next parameter is going to be the factor by which the window is scaled between subsequent scans. What we're going to do in the next two conditional statements is for a slightly slower but more accurate detection, we're going to make this 1.1. But here we're going to keep this 1.2. And now our next number is the minimum number of neighbor rectangles. The higher we make this, the more accurate the detection is going to be, but it's also going to take a little bit longer. So for the fastest possible detection, we're going to start out with a relatively low number of 2. And now the next parameter is a constant do_canny pruning. Currently this is the only option available for the function. And for the last two parameters, if we use size.empty, that will specify the size in the XML files. If we specified anything else, this would be the minimum window size and maximum window size of what we're trying to detect, either the faces or eyes. And now we're essentially going to do the same thing for eyes, and then we're going to do the same thing in the remaining 2 conditional blocks, only with slightly different parameters to balance the speed versus accuracy trade-off. Okay, so after having copied and pasted from the first conditional statement, we're simply going to change the factor by which the window is scaled between subsequent scans and the minimum number of neighboring rectangles to sacrifice speed a little bit more for the benefit of more accurate detection. So we'll go with 1.1 and then 3. And 1.1 and 3. And then for the slowest but most accurate detection, we'll go with 1.1 and 10. And for eyes, we'll go with 1.1 and 25. Now note, if you were doing a live stream from your webcam, you'd pretty much have to go with something that would be really quick, such as the 1.2 and 2. This would take way too long. It might take a full second or more, as we're going to see momentarily when we test our program. So that completes our detect calls. And at that point, the timing should stop. So we'll put our end time code for the stopwatch. So now we've found our faces and eyes, and those are in the average count faces and eyes objects. So what we're going to do is for each of those, we're going to have a for loop that's going to step through each face and eye, and then draw a rectangle at the applicable point in the original image, and then we're going to display the original image. So that's going to complete our program. Now we can go ahead and do a compile. And that's a good sign, one succeeded. So let's go ahead and fire it up. And we'll maximize the window. And so the first thing that we can take a look at is choose Haar face file, choose Haar I file. So for example, if we click on the Haar face file text box, then we can navigate to, by default, when we set up the form code, we put the text box text to Emgu Windows x86 OpenCV data and Haar cascades, and to go to this Haar cascade frontal face default.xml file. But we could choose a different one if so desired. For example, you could go to OpenCV 2.3.1 OpenCV data and Haar cascades, and then you could choose frontal face alt tree, alt 2, or default. And then same for the eyes, there are other options also. But for our example today, let's just stick with the default. So we'll go back to the Emgu CV Windows x86 OpenCV data Haar cascades and Haar cascade frontal face default. So once you've either left the Haar face and I XML files as the defaults or chosen the ones you prefer, then we can click on choose image file, and then you can navigate to the image file of your choice. I just happen to have a few sample images here in this pics directory, and let's take a look at some of the results. So you're going to see the default Haar files work pretty well. For example, here we have 2 very nice face detects and 6 nice eye detects. Newt's jacket here we have 1 false face detect. This next scene doesn't work all that great because a lot of the faces are kind of pointed at an angle, so we only have 2 face detects and no eye detects. That's understandable though. This person in the back here has their hats covering their face slightly. That's kind of shaded, so that's a difficult scene. This next image here of Lieutenant Corpsman is a very good picture. We do have 1 false eye detect, but we do have a good face detect and 2 good eye detects. And in this next image here, we have some good detects for Ripley. Some of the other folks in the scene aren't detected quite as well. Here we have a false eye detect and a missing eye detect, but a good face detect and 2 good eye detects at the center. And generally speaking, the better the lighting is, the better the result. Here we have an outside image, and we have a very good face detect and 2 good eye detects. Another good face detect in the background here. We're missing some eye detects, but it's understandable because Newt's eyes are largely closed there. And this next image is an example. The left eye and right eye functions would probably work better. Here we're missing an eye because of the lighting on the side here. But we do have at least 1 good eye detect and a very good face detect. And this next image, this is a reasonable result, all things considered. Of course, the lighting in this picture is a little bit awkward because Ripley is burning the alien eggs with a flamethrower, but even with the lighting being kind of odd, we still have a very good face detect, although we are missing the eye detects. Now this next image works out pretty well. Background noise can kind of be a hit or miss thing. There's some noise in the background as far as the snowplow and the truck. But even so, we still have a very good face detect on hue here and 2 good eye detects with no false detects. This next image is one where the background noise didn't work out quite as well. On TJ here we have a very good face detect and 2 good eye detects, but we have multiple false eye detects and even a false face detect on TJ's jacket. So that wasn't the greatest of results. Now here's one where it's outside. These generally seem to work better than inside in my experience with these algorithms. We have a very good face detect on Alex and 2 good eye detects and no false detects. And then back to an inside scene here with the dispatcher, good face detect, missing 2 eye detects, but it's understandable because the glasses are slightly shaded and the eyes are not really closed but not all the way open and visible. And in this next image here, we have a good face detect and 2 good eye detects, 1 false eye detect, 1 false face detect. And in this image here, despite all the background noise and the jacket and so on, we still have two very good eye detects and a good face detect and no false detects. And this image of Lena here is the image that ships with the samples for OpenCV and Emgu CV by default. Of course, with the algorithms provided, the example image works well, so we have a good face detect and two good eye detects. Congratulations! You now know how to perform face and eye detection on still images using the Haar face and eye.xml files that are included with OpenCV and Emgu CV. I've got some more OpenCV videos planned for the near future, as well as some other videos, so please stay tuned to 18F4550 videos.